let me now come to the second mystery of the whole thing, namely, what is DMRCP? Oh, I forgot one acronym. Those of you, I told the camera person that what is on the board is not so important for the, oh, I moved it out of your view. Not so important for the online participants, because you, of course, all know these acronyms, but it might be important for the people in the room. So what is DMRCP? DMRCP is a SIPCH chair. SIPCH is the second acronym there. What is a SIPCH chair? What is SIPCH? Well, we are entering the mysterious world of global science organizations, where everything has an acronym that has at least 5 letters and some more, and no one has any idea what these institutions actually do. So the one institution that most of you probably do know is UNESCO, right? The United Nations Educational and Scientific and Cultural Organization. Probably most of you don't really know what UNESCO does. Neither do I. So UNESCO does some things. UNESCO is really the UN body for education and science. And it delegates some of its tasks to more disciplinary bodies, namely the International Science Council, ISC, and the International Humanities Council, SIPCH, Conseil International de Philosophie et des Sciences Humaines. And I want to establish the English translation International Humanities Council for it, even though it is not a direct translation, because it highlights the duality between the International Science Council and the International Humanities Council. These two councils are umbrella organizations, and their members are not people. They are not even institutions. They are institutions that have institutions as members. So they are umbrellas of umbrellas. So their members are unions, and the unions consist of the learned societies representing their subjects. For example, a union that you actually do know, the International Mathematical Union. Right? That's a union where the members are the learned societies in mathematics in the countries, and it is a member of the International Science Council. Another one that you should know, I hope some of you do, is the International Union for History and Philosophy of Science and Technology, which is the union to which you belong. Well, more technically, you belong to its division of history of science and technology. And in fact, that division is a member of SIPCH. And the union is a member of the International Science Council. And you see, I'm a set theorist, right? So I actually do layers of structures. So this is what I thrive in. Anyway, let's come back to what is a SIPCH chair. So, and in order to explain this, I first need to say something about UNESCO chairs. So UNESCO chairs are slightly more well-known than SIPCH chairs. They have somehow made it into the general, the general discussion, literary discussion. For example, the late David Lodge, in his novel Small World, this is a novel about academic travel, and it is modeled after the Arthurian legends, where everyone is trying to find the Holy Grail. And in that novel, the Holy Grail is a UNESCO chair. Of course, all of these people are going to the conferences because they all want to become the UNESCO chairholder. Now, UNESCO chairs in reality are not professorships that someone gets, but they are networks built around a professorship somewhere. So usually there's someone who is already at a university, and this university says, we are building a global network of research around this person with a UNESCO chair. In practice, because this is all highly regulated by the national UNESCO commissions in the various countries, it is extremely difficult to establish a UNESCO chair unless the main focus is educational policy. So that is really what UNESCO wants to see. And SIPSH said, this is very sad because some of our humanities projects are very interesting, but they don't focus entirely on educational policy and therefore are not able to become UNESCO chairs. So 8 years ago, SIPSH decided to create their own chairs program, modeled after the UNESCO chairs program called SIPSH chairs. And they are exactly the same thing. So it is someone who has a network idea, who proposes that this gets the label SIPSH chair, and then it is created as a network. And our SIPSH chair is called DMRCP, Diversity of Mathematical Research Cultures and Practices. And as all of these SIPSH chairs, it is extremely transdisciplinary. It involves sociologists, psychologists, cognitive scientists, historians, philosophers, also mathematicians. And it is driven by the observation that traditional views of philosophy of mathematics paint a picture that mathematics is monolithic, that it doesn't depend on humans, it is the same everywhere. And that is something that is just not true, as every mathematician and historian of mathematics knows. So this is about collecting information about differences in mathematical research cultures and practices and how they actually affect mathematical research. Obviously, historians of mathematics play a major role here. So you are sort of the diachronic version of this, whereas this is more focusing on the synchronic version. So the way the chair works is we have a council consisting of the senior fellows, and we have a fellowship which is elected by the council, and everyone who is interested in joining the work can ask to become elected as a fellow and join the group. And the main activities, and now we come full circle, the main activity of the SIPSH chair are its regular online seminars. And this is the 9th of them. And at the moment, our seminars, because there are many fellows and not all of them are known to all of the others, at the moment, the main purpose of the seminars is that people answer the question, who am I and what am I interested in? So usually we have these 2 or 3 talks per seminar where someone stands up and says, this is me, this is where I come from, this is what I'm interested in, and are there any others like me here in the room? And this is what we are going to experience today, because we have 2 of our fellows who haven't presented themselves, and I find it very nice that both of them are actually participants of this program, even though one of them is online, so that we actually make this slightly more topical to the program. The attempt here is to bring DMRCP together with the participants of MHM. And now, of course, it would be good if we get a similar introduction to MHM so that the people online understand what this is about.
Thank you very much, Benedict. So, hello, people in the room. Hello, online viewers. You can see me. Wonderful. So my name is Adrian Rice. I'm one of the organizers of the MHM, the Modern History of Mathematics program here at the INI. My other co-organizers are June Barrow-Green, Chris Hollings, and Troy Astasi. This program is already running from January the 8th all the way through to the 2nd of May. It features a variety of activities, probably close to about 100 historians of mathematics will come and go from the INI over the next 4 months or so, participating in a variety of activities. Many, probably most, will be doing things related to their own research. Some will just be working on their own or in small groups, but we have specific, what we call mini workshops devoted to specific areas where certain research groups have sort of coalesced around particular subjects or issues. The first of these mini workshops has already happened. This happened between the 8th and 17th of January and was a mini workshop organized by my colleagues Della Dombau, Sloan Despo, and Gemma Laurenat. And this was on the life and work of Oswald Veblen. And this group met extensively over a period of just under 2 weeks, and they are working on a series of papers on aspects of Veblen's work, which will ultimately be submitted for publication in, I think the Bulletin of the AMS is the venue where that is going. Another mini workshop that will start, or actually has just started this week, is a much smaller group of scholars under the direction of June Barrow-Green, working on an aspect of the history of dynamical systems. Then in about just under 2 weeks, we have Volker Remmert and Rebecca Voldecker leading a working group on the history of the classification of finite simple groups. That workshop will go on for about 5 weeks and will also feature on the 4th and 5th of March, a 2-day seminar series entitled New Structures in Mathematics, for Mathematics, of Mathematics from the 1940s to the 1960s, featuring a group of invited speakers. Another mini workshop taking place during our program will be run by Karine Schemler, Paul-Emmanuel Timothée, and Nicolas Michel. And this is on the translation project for the Brill-Noether report from the 1890s on algebraic functions. And this will run for 2 weeks from the end of February to the beginning of March. And they also have organized a series of seminar speakers to punctuate their mini workshop. Lots of names there. The ones that occur to me from the top of my head include Jesper Lutzen, Jeremy Gray, and David Rowe. David Rowe, in association with John McCleary, will also be organizing another mini workshop research group, this time on the 20th century history of three manifolds, which will be taking place in the first 3 weeks of March. And then at the end of March, the last week of March and the first week of April, there's a very big mini group coming together to work on the history of computer science and data science. And that has lots of different activities going on in the fortnight that they're here, including a 2-day focus on literacy, computer science, and mathematics in the 20th and 21st centuries, organized by Lisbeth de Mol and Michael Friedman. And also another 2-day series on the evolving landscape for the history of data and statistics, and that's organized by Deborah Kent and Gemma Laurenat, and that will take place 31st of March and 1st of April. Also, as if that wasn't enough, this group has also organized a half-day satellite meeting in the Cambridge Computer Science Department on the theme of where did AI come from, which will feature a talk from, I think talks from 3 MHM participants as well. And also we're in the early stages, or rather Michael Barani has very kindly volunteered to organize a 2-day focus on provincializing modern mathematics, which will run, we hope, on the 15th and 16th of April. That's in the early stages of organizing as well. So thank you to Michael for organizing that. So these are some of the research groups and topics that will be underway during the next few months. In addition to that, we have other activities planned as well. For let's say, a broader audience. For example, we're very pleased to have Portrait Theatre Vienna come and give us a performance of their one-woman show, Diving into Math with Emmy Noether, which I have actually seen when it came to the United States. It's a very, very well put together play, a one-woman play on the life and work of Emmy Noether. And I do encourage you to see that if you can. It will be here on the 11th of March. In fact, there will be 2 performances on the 11th of March. We also have public lectures sponsored by the INI. The Rothschild public lecture will be given this year by Reinhard Siegel-Schulze, and that will be on the subject matter of his 2009 book, mathematicians fleeing Nazi Germany. That will take place on the 27th of March and will be open to the public and will be live streamed and recorded. There will also be another public lecture on the 23rd of April, the Kirk public lecture given by Clemency Montel from New Zealand, and that will be about aspects of Indian mathematics and current work there. In addition, we have what we could probably call more major workshops. So we're talking about mini workshops, these little focus groups that have been that will be operating throughout the program. Those of you who were here last week will remember that we had a very big opening workshop. The opening workshop of the program was entitled Emerging Themes, where we had a group of about 20 speakers speaking on various aspects, answers to a specific question, and then we came together at the end to bring together some emerging themes arising from those talks. There will be another workshop next week organized by Isabel Faulkner, and this will be on the history of modern mathematics in higher education. This will take place next Tuesday and Wednesday, so February the 4th and February the 5th, and we have a variety of speakers lined up for that. June Barrow-Green has organised a satellite meeting to be held at the London Mathematical Society headquarters, De Morgan House in Russell Square in London, on the theme of the history of mathematics in mathematical leadership, where we'll have a variety of representatives from various mathematics departments throughout the UK. And the basic question will be, what can the history of mathematics do for you? Finally, at the very end of August, from the 28th of August to the 2nd of May, this program wraps up with a final major conference, the closing workshop, which will be organized by my colleague Chris Hollings on the theme of looking ahead. And in contrast with the opening workshop last week, where we had was dominated by senior scholars answering specific questions, the closing workshop, looking ahead, will be devoted more to early career researchers, more junior scholars, giving their impressions not only on what the future may hold, but also on the work that they have done during the last 4 months. So that, in a nutshell, is our program, and I'd be happy to take any questions. Thank you.
Well, I mean, the obvious question is, are there some of these workshops still open for participation for people who haven't signed up yet? For example, the closing workshop.
The closing workshop, yes, there's, my instruction would probably be email Christopher Hollings. I can write up his email. He's the organizer, and he, I think basically the idea is that there is a certain amount of money that organizers of workshops have to help facilitate people actually coming here, staying, helping with accommodation, food, etc. If people are able to fund themselves, of course, then all they just have to do is just tell them that they're coming. But in terms of financial aid for that, they should email Chris Hollings.
So in general, those of you who don't know the Isaac Newton Institutes, the building is in principle accessible to anyone. So you just go to the reception desk and sign in, and then you can attend things. So it's a very open environment. In case someone who has funding would like to come to Cambridge and go to some talks.
Yes,
that's highly recommended.
Yeah, indeed, that's true.
Okay, should we move on to the main part of the seminar? As I said, we are usually having two presentations answering the question, who am I and what am I interested in? Normally, Deborah, the other Deborah, Deborah is chairing these things. She is the scientific coordinator of the SIPS chair. And so today, I think it might be a good idea if she is chairing the online part, and I will be chairing the in-person part. And as I said before, please do interrupt. And that is true for everyone online, but also for everyone in the room, because we want this to be an exchange. I noticed that once the slides show up, everyone who's online will disappear from sight. But that should not keep people who are online from interrupting. just means that your voice will come out of the void, but just accept this. So Deborah, to you.
Yeah, I'm very happy to introduce our first speaker, David Waszek. Yeah, who is, as was already said, also a member of the participant of the MHAIM program. So the stage is yours, David.
Thank you very much. Can you hear me?
Yes.
Yes.
Perfect. Perfect. Thank you very much, both to the DMRCP network and to the Modern History of Math program at the Newton Institute for giving me this opportunity to present my research. I was asked to do a presentation in 10 minutes and, if possible, without slides to avoid the problem Benedict just mentioned. So I'll try and do that, do my best to be concise and clear, even without them. So, in general, my research straddles the history of mathematics and the philosophy of science, especially of mathematical practice, but I mostly focus on my historical work today, also in line with the interests of the Newton Institute program. Broadly speaking, I am interested in the way mathematics is expressed and written down, the notations one uses, the use of diagrams, the definitions one chooses, the way one structures one's texts or computations. Why this theme? One important reason, and that's how my work is most directly related to the DMRCP workshop network, is that this is a way into the diversity of mathematical practices. Indeed, obviously, there are many ways of writing any particular piece of mathematics, many notational choices, many definitional choices even, and the choices made by practitioners reflect specific values. One theme that has been of particular interest in the philosophy of mathematical practice recently is the question of particular virtues practitioners may want their proofs to have. For instance, that their arguments should be linear, should be synoptic, should be clear where each step follows from, where each step comes from. Perhaps one might want the proofs to be explanatory in some sense, show why the result holds. And also one could be interested in virtues of broader sets of statements, how unified one theories are, how modular, and so on and so forth. And I believe many of these virtues that have been discussed are, at least to some extent, representation sensitive. They depend on how we write things. And so that's how the two themes most directly connect. And that's one of the core motivations of my research program, so to speak. I start with one more in-depth example of my work, and then give brief presentations of other projects I'm currently involved in. So fundamentally, to approach this question of forms of representational choices, notational choices, and the virtues linked to them, virtues and values linked to them, my method is historical. The empirical grounding of my work is the history of math, and my method is to develop in-depth historical case studies. So the first example I want to bring up to give you a sense of what I do is a small notation or notational change introduced by Leibniz and that then circulated quite widely, that I've studied in my PhD, but have been revisiting recently in light of new manuscript evidence, connected to some of what you've heard last Monday for those of you who were at the opening workshop at the Newton Institute. The small notation in question is an exponential notation for a higher order differential. So Leibniz used to write the differential of a quantity x dx, and then from there, you can construct the second order differential d dx, third order d dx, and so on. And the point of this small notational change is to use exponents, d square of x instead of d dx, and so on, and also d minus 1 of x for the integral of x. That's the notation in question. Now, and I want to be as cautious as I can here, this notation is somehow closely related to a discovery often ascribed to Leibniz, namely an analogy between powers and differences, as it is often called, namely an analogy between the powers of a sum, x plus y to the power n, and the higher order differentials of a product, d to the power n xy, which for Leibniz also extended to the case where n is negative. So you can develop integrals into infinite series, or you can develop fractions to infinite series. Now, in the literature, you can find many dubious claims about this notation, that it led to Leibniz's discovery of the analogy, that it shows beautifully how Leibniz's notation perhaps is superior to others. It has been enlisted into many kinds of battles of this sort. And here we encounter a serious methodological difficulty. In fact, it's very easy and it's very often done to make up just so stories after the fact about what a notation may have made possible, or what it led to, or what not, which I think is part of why the whole topic may appear disreputable to some. In fact, the questions we face with respect to such notational choices are tricky. What motivations, for instance, did Leibniz have for introducing this notation or initially experimenting with it? How independent were those motivations from what the notation may have led to? What role did the notation actually play in the research process, as opposed to other ideas, not strictly speaking notational, that Leibniz or others may have had? What about the motivations and practices of the many collaborators of Leibniz, and in this case in particular of Johann Bernoulli? So my work has looked at very closely at correspondence, drafts, and so on, with the goal of reconstructing the research process and trying to address these questions in a very rigorous way, as much as I could. And what I could conclude is that the notation did play a guiding role to some extent in Leibniz's research process. One can reconstruct why Leibniz introduced it, can see that this is different from what it later led to, and one can see what kind of guiding role the notation may have had. But this raises an interesting question. So why did Leibniz introduce this notation in the first place, and what kinds of values may have driven this choice? And here, I think what we see is that Leibniz prized the notation's ability to express a certain family of results under the guise of a certain uniform formula that had certain symmetries. So some expressive properties of the notation were what Leibniz found particularly compelling there, and what made him want to experiment further and look more deeply at what could be done with it. And this, I think, these particular values among Leibniz's collaborators and contemporaries were quite specific and quite peculiar. And I think seeing this helps us maybe think more deeply about something that is quite present in other mathematical practices as well, and not just Leibniz's. Namely, what goes into mathematicians' judgments that some definition or some approach is natural. What kind of features do they latch onto to think that this is a promising avenue, like Leibniz did, for this kind of uniformity that he could see in the formula? And there we can see interesting differences and interesting features of specific mathematical practices that I think are quite interesting. So I think this gives you a sense of the flavor of what I do. And I want to say now a few quick words about some other projects. First, I want to mention a joint project with Nicolas Michel, whom those of you who are in Cambridge may have met already as his, so to speak, the embedded postdoc of the Isaac Newton Institute for the Modern History of Maths program. And together we've been looking at what we now call enumerative geometry, an area of maths basically that investigates questions like how many conics are there in general that like are tangent to 3 given lines and pass through 2 given points. And we've been looking at the role of notations and the various values associated to notations in the history of this. And in particular, we've been looking at a French mathematician called Georges-Henri Alphen and his work in the 1870s. We have many of his drafts as well and rulings, so it allows for doodlings, and so it allows for a kind of investigation that I like. Currently, I'm employed by a project under the direction of Christophe Ekes and Emilou Hafner in France. Emilou, who is also a member of the DMRCP network and of the MHM program, a project on the Bourbaki collective. The Bourbaki group is now known mostly for their immense undertaking, started in the 1930s to write a giant maths textbook, the Éléments de mathématiques. Essentially, they wanted to rewrite maths from the ground up in a modern structural style in some sense. And they had a very interesting collective writing process. One member would write a first draft, they would comment and criticize it together, and then another member would be tasked with writing a follow-up draft and so on, which created lots of archives and also helps us see what they were aiming for and what they were trying to achieve by writing the theory in a certain way. And so this is very interesting for the historian and helps us, I think, describe more clearly the peculiarities of this so-called modern way of writing mathematics in a very interesting way, which actually is a quite peculiar mathematical practice. Finally, I'll finish in a few seconds. I've been quite interested in the history of thinking about notations. So how people try to conceptualize the role of notations. And in this respect, together with Dirk Schlim, also a fellow of the network, we've been looking at reflections on this in the algebra of logic tradition in particular, and more broadly in 19th century algebra. And we've written some papers on this, and more recently, I've also been engaged in studying this more and publishing some further manuscripts, in particular by George Boole, whose reflections on notations are less read, I think, than they deserve to be, and are quite interesting in their own right. Okay, that's all I wanted to say today. Thank you very much for your attention, and I am very much looking forward to the discussion. Thank you.
Thank you very much, David, for your presentation. So, do we have any questions? I think in the room, someone else should.
Yeah, well, you can see the room.
Yeah,
yes.
but.
Yeah. Go ahead.
So thank you. It's very interesting. I hope you can hear me. I have a question that perhaps is not formulated clearly enough, but I was struck by the fact, and very well impressed by the fact that you refer very often to the motivations of the author. So you talk about what motivates the author. And so there are, in inventing a notation, let us say so. So I would like you to tell me something more about how you probe the motivations of an author. And if you think that the text that an author produces, the notation that an author produces, is somehow independent from the motivations of the author. I mean, what Leibniz did was rediscovered by the British algebraists at the beginning of the 19th century in a somewhat different context. So I wonder whether in your research you deal with this complex relationship between the motivations of the author, the text that an author produces, and the independence, in a way, of this text from the motivation, something that in mathematics is quite prominent in certain cases. Thank you.
Before you answer, let's briefly say hello to Ursula. Hello.
Hello, Ursula.
Now.
I don't know if that worked, but hello as well. And yes, thank you very much for your question, which raises some quite deep questions. So first, the question of motivation is very interesting one, and I think that's why, in a sense, this is a shorthand for saying pointing to the research context. and the kinds of questions that were pursued. And so I think this is where drafts are a particularly fruitful kind of source, notebooks and drafts, and also correspondences where people report on their research, and a broader view of the kinds of questions one can see them trying to answer. And in this particular case, well, Leibniz is maybe an extreme case of an author who was almost graphomaniac in a sense, who would always, perhaps to a more extreme extent than I have seen anywhere else, was basically doing his thinking on the paper and seems to have been writing constantly. And so this, in a way, is precious for this particular purpose, because you can see the kinds of questions he was asking and trying, and then striking it out and trying again, and then also writing text about what he's trying to do and what his thoughts are. And there you can see, for this particular notation, for instance, you could imagine various sources. I don't want to be too long, but so more conceptual questions like, oh, it seems that there are similarities between algebraic equations and differential equations, and the pairs of operations between differences and sums seem to behave like powers and roots, or maybe it's powers and fractions. It's not clear. And so you can see him feeling his way there, but you can see that it's not quite what's happening when the notation is introduced. So that's the kind of evidence that I want to marshal here. And then also to see what context exactly was it that he says, well, now let's see if you write it this way here. Look, you have this nice formula, and oh, this looks amazing. This is the kind of thing that we want. And so here you can see the kinds of things that he prizes, and so why he feels attracted to this notation at a particular point in time. Now, I don't want to be too long, so maybe I should address some more the question of rediscovery. So, in fact, there is a very interesting rediscovery story about this, which is Lagrange, as a teenager, basically rediscovered what Leibniz did, and sent it to Euler, who didn't reply, and later told him, oh, actually, you see, it's in the correspondence of Leibniz and Bernoulli. But there is a twist in there, because in a sense, part of the notation, not all of it, but part of the notation had circulated. And that's actually, in a sense, Lagrange was rediscovering something that was in a way in this trace there to some extent. But for the broader question of rediscovery, I think the main thing I want to say is that the way I want to think about it is not necessarily just focus on the independence of the particular episode, but I want to think the various ways one could do it and one could write it. So of course, then you could say Taylor did something very similar using a Newtonian notation to what Leibniz did. Other people might have written it in other ways, and then as historians, we might see similarities and might say, is this the same thing? Is this not the same thing? But this has to be on the background of many different possibilities and a space that is much less constrained than one might think. So then, you know, Leibniz, because of his particular question, will go in the direction where the integrals play an important role. Maybe others will be interested in this similarity, but not look at that. And so I think it's what we recognize as being the important result will matter in how we read this. It's not, there isn't a single answer. I'm being a bit too rambly and confused here, but that's the kind of thing I would want to elaborate on more at length in another context. Thank you very much for your question. I can't actually see you very well, but I see you there. You're there, so thank you.
Thank you. Thank you very much.
Yeah.
Adrian.
I'd like to follow up on Nicolo's question, because I was thinking that...
You're just outside of the shot.
Oh, I'll come in.
Yeah.
Here I am. Let's see. There we go. There we go. Well, kind of. I'm thinking very much from I'm thinking very much from a pedagogical point of view of the idea of Leibniz's introduction, and as Nico said, this was rediscovered by British mathematicians in the early 19th century, the idea of representing, I suppose you could, composition of functions with the same notation as powers or combined multiplication. And what I have observed as a teacher is that this causes immense confusion, because I thought that the purpose of mathematical notation was to make things more obvious and more simple. And what I find is that if you write down sine to the power of -1, that means the inverse of the sine function, but a student just beginning will think it means 1 over the sine function. Now, that to me completely obliterates the point of good scientific notation or good mathematical notation, in that it obscures what it's meant to clarify. In other words, what it's doing is the reason it obscures it is because it is using the same notation to the power of -1 for two different things. One means a reciprocal, another one means an inverse. And so my question to you is, does your research or your work take into account the correspondence between a mathematician's motivation for introducing notation and its ultimate effect?
Yeah, so thank you very much. So it's indeed important to distinguish the two things. As a point of just a historical point, I just want to say that the continuity between the early 19th century British work and this Leibniz work is not non-existent, and that in fact this came through precisely Lagrange, Laplace, and people like Savoie and so on. So it's maybe less of a rediscovery than it seems, although motivations were somewhat different indeed. But then on the question of the effects, indeed, I mean, I think the point is that maybe there isn't such a thing as a good notation in the abstract or independently of precise goals and involved in precise practices. And indeed, it's true that the two can have different contexts. It can have different effects. I don't doubt that. I guess I'm interested in indeed the specific values and that might guide the choice of notation and specific roles it might have. And in this context, I think it might obscure things for the students, but in the episode in question, it did play an important role, even though you see traces of the confusion when the notation circulates to Varignon. He's confused, is impossibly confused, and you see endless letters with Bernoulli trying to understand what's going on, and it takes so long. But the point is that, in fact, this ambiguity that you point to is exactly what makes it useful for them in this specific context, or at least from a retrospective point, we could call it helpful, even though we want to focus on the effects maybe independently of what we think it led to. But it's because the way you write it, this goes into the thing that I haven't developed much, is how we can see it shaping the kinds of questions that people ask and the kinds of research they do. And so in this case, it encourages questions like, how far can I take the fact that the behavior of these things will be the same? How far can I manipulate these things so that they are similar? You know, what kinds of patterns might be similar between the two things? And it also changes what you can express with it in a simple way. So for instance, it makes it easier for Bernoulli to experiment with certain things that will, you know, could be reinterpreted in terms of operational calculus later on, but without the notation, it seems difficult to get a grasp on what the rules are that you might want to try. And so I think these are really questions I'm very interested in understanding, you know, what does it do? How does it shape the kinds of questions they ask, the kind of research that is easily accessible to them? And then, of course, how is this influenced by the values that might have led to the notation in the first place, which creates a kind of path dependence and, shows how much the practices are maybe governed by specific concerns and, not so universal as one might think, even though, of course, there are similarities. And yeah, sorry for, again, being a bit rambling.
So is that something, Dirk, are you there? This seems like something that you should be able to comment on the basis of cognitive science. You are, after all, the philosopher of notation, right? you invented the field.
Well, me and Peirce. By the way, I use this here for a shameless plug. This Cambridge Element on mathematical notations that I've written will appear tomorrow. And it will be free for download. So go to the Cambridge Elements and get everything I know about notations.
And if you want to get the paper copy, the Cambridge University Press bookstore is, of course, very close.
Okay, thank you. Well, one comment I had on Adrian's question about whether it's a bad notation. I think one aspect to keep in mind is kind of that when we look at notations is who are the users, right? So it is true that something that, and the notations often are invented by the experts in the field, right? Yeah. By doing their advanced thing. But then we use the same notation actually, to teach people who have much less background, right? And that's, in the sense, well, it's not surprising, I would say, that there's this disagreement or these problems, because in this case, the users come with very different background knowledge and very different expectations and so on. So in principle, yes, I think it's bad to use kind of the same mechanism in the notation for different purposes. But maybe it's bad to have this idea that there's one notations that the experts use, and that's the same one that the students use, right? So it might be better, perhaps it might be good to have this kind of more kind of tradition to have. For pedagogical purposes, we do it this way. And then for other purposes, we do it that way. In particular, since experts tend to to invent shortcuts and in all kinds of ways, right? That might be even difficult to communicate. So I think it's just a matter of one should be more kind of pluralistic in the sense that David also said, looking at kind of who's actually using it, right? And there might not be a good notation, as David said, in the abstract, right? It always depends on what for and who the user are.
This of course highlights the way that we usually think higher education works. So the reason why we don't want to invent independent notation for teaching purposes, because that would mean that all of these people we are training then have to relearn notation when they become serious scientists. And of course, in some sense, maybe secretly, that's the part of the student population that we actually want to teach. And therefore we want to prepare them for the more serious things. I had a question for David about which is related to the earlier question. Oh, now I went out of shot. This methodology of finding out what the motivation is. Right? So you mentioned this. This was mentioned in the case of historical things where we are relying on people actually writing down something. Would you say that there is a methodological difference for dealing with motivational questions for current events? So for example, if this is about studying something that happened 4 years ago and we have to say something about the motivation of the authors.
Thank you. Let me think. So, I guess since several questions have broached this question of motivation, maybe I should say that I want to be to emphasize too much, to be too much of a realist about motivations of people and what they wanted to do and so on. I want to overemphasize this point. However, I think certainly understanding the trying to get a grip on the values, trying to get a grip on the research problems that people were trying to get at is very important. Now, one thing I would be cautious of is if we're talking about recent events, and one would want to be quite cautious about oral history, or maybe just looking at what people say after the fact, and that could also hold, of course, for historians, and a source that's much later than what happened, and people say, "Oh, this is the history of," which was a genre that got important. Of course, after in the Leibniz case, because of the calculus controversies, one might have to distinguish between the stories that the actors might want to tell about these things, and what we can figure out and what we can surmise as historians. And in this case, it can be tricky for very recent events as well. That's, I guess, the fuller extent that I'm willing to say, because I don't think I have thought of this enough.
Michael, interrupt. You trained interrupting.
Oh, yes. No. So I think maybe just one dimension that struck me in Adrian's and Dirk's and your last remarks, Benedict, that I think connects to this really lovely observation that David made about the role of just so stories in histories of mathematical notations. I think it also connects, for those who were at the workshop, at the conference last week, to Karine Chemla's presentation, is the way that often in writing about mathematical practices, mathematical notations, and so on, there is a tendency to over-identify with one's subjects, so that the historical actors or the situated actors get subsumed into this first-person plural. The how do we write? How do we train? How do we understand? And I take, maybe this is sort of over-projecting on you, David, I take one of your interventions to be that we really have to resist the urge to put ourselves in the shoes of, or in the notebooks of the people we're studying, and that this sort of practice of externalization is actually a really needed intervention in the philosophy of notations and otherwise. But maybe that's more of a comment than a question, but maybe it's a comment that can be a jumping off point.
No, absolutely. I think you're right, and I think it's I mean, I think there's a bit of an ambiguity, because of course when you're trying to not look at just published sources, and you're trying to look at the research process, in the sense you want to reconstruct something of the environment and the thing, the questions, the kind of work the person was doing, and so on. And so in that sense, it is both a necessity and a risk to do an element of this putting oneself in the shoes in a more in a broader sense of putting oneself in the environment, maybe to some extent, or trying to reconstruct it. But then, yes, that's absolutely true, that one may want to have distance and try and be attuned to the gestures that maybe we find strange, or we don't understand, or the reactions that and so in particular, for instance, why at this particular moment does Leibniz write, "Oh, now I see that there's something real here," or that, there's a kind of distance taking and defamiliarization that is maybe easier there because of the fact that the source is older, but where we can see that maybe we could also do these computations in a way, but the way the path he chooses to take, and the things he's interested in, and the reaction he has, we cannot so easily identify with at first. There has to be a distance and something foreign, an alienness to it, is what is interesting about it.
So we'll have to move on to the next speaker in a moment. Let me abuse my power to make one more comment. There's something that you said, maybe not even as a main thing, but it linked to my own interests in the practices of mathematical publishing. And that was, you said, the Vrhovski thing was very unusual as a style of writing papers together. And I thought about this, and I'm not even entirely sure that I would know whether that's true. It was certainly unusual at the time, but nowadays with co-authored papers, we may actually be getting closer to that style where versions are handed around and various people are writing something. But of course, I have no empirical data on this, and some more research needs to be done because we actually don't really know much about how papers are written at the moment. That is really something that should be looked at. Okay, now we are actually moving to slides, which means that, sorry for you, you will disappear from sight for a moment, but we will restore you as soon as we can. And I suppose this happens automatically. Or do we have to do something? Oh, it didn't disappear from sight. Good. Perfect.
So first, I would like to thank you for having me here today. It is really hard to speak after David's brilliant presentation. I will try to be really short and really terse because I'm still kind of in the starting phase of my research. So my research will be full of different keywords and different graphs, which is why I need the slides so desperately. I will try to present my research in the framework of a research project I'm currently working in. So my name is Vrhovski. I'm originally from Slovenia, and I'm currently working at the University of Edinburgh. More specifically, in Michael Barani's Sigma project, which is situating international and global mathematics. The project will extend between 2023 and 2027, which means that we are currently in the first year of our work together. The project it currently consists of 3 people. Michael Barani is a PI, and Dr. J.P. Asher and myself as the current postdocs. It's still a work in project, very much. Work in progress, very much. I'm still trying to find my own voice and direction within this really interesting and, for me, very much demanding project. And the demanding aspect comes from the fact that I'm kind of scattered as a scholar, so to say. My previous focuses include history of logic in China, plus history of Chinese logic, history of Chinese modern mathematics, and modern Chinese intellectual history. I've also spent some time studying philosophy of Ludwig Wittgenstein. So you can see this current map of where my ideas are at the present. And in the framework of Sigma, I'm focusing on 3 different things. First of all, history of mathematical bibliographies, and especially classifications. In the framework of this sphere, this is a collective interest which we share with all the rest of the members of the cluster. I'm in the framework of which I'm mostly interested in development of German and French bibliographies at the turn of the 19th, 20th century, more specifically Jahrbuch and Revue semestrielle. The second major field of interest, which I'm very much interested in right now and which connects to my previous work, is history of topology, mathematical logic, and set theory. When it comes to history of topology, I'm interested in the less known beginnings of analysis citizen topology in Europe in the early 20th century, tracing the less well-known developments outside of the major centers like Göttingen, for example. As a part of my previous projects, I'm also working on history of mathematical logic in China. Currently, I'm starting to convert I'm starting to converting my PhD thesis on history of mathematical logic into a readable and interesting book for Western audience as well. And then there is the third sphere of the third collection of interesting topics I'm working on right now, which is analysis of lists and structures in modern mathematics. I will tell you more about that a little bit later. And because I come also from sinological background, I'm also very much interested in methodological issues which connect these two different aspects of my academic life together. The methodological issues I'm interested in are actually a collection of questions which pertain to historiography of Chinese mathematics and how to deal with Chinese mathematics in the framework of modern classifications, etc. So now I will present to you two sneak peeks into what I'm currently working on together with the rest of the team. So sneak peek number one is bibliographies, institutions, and epistemologies. Most particularly, I'm interested in how different bibliographies, the early bibliographies, are used to create two different images of mathematics. The structural image of mathematics on the one hand, which is underpinned by different epistemologies, and the institutional geographical image of mathematics on the other hand. Sorry. It's just because I come from sinology, I'm also dealing with communist spirit in China, which is really challenging, so to say, for the image of mathematics internally and externally for the Chinese. As extreme examples, I'm also trying to take a look at, let's say, Chinese communist mathematics and how different epistemologies changed the ways how bibliographies were formed, how they changed classifications, how they remodeled the institutional geography of mathematics within China, and also how the same thing happened in the Soviet Union. I'm trying to use this as extreme examples of how epistemologies can affect the way, so to say, neutral bibliographies are conceived and circulated. And the sneak peek into my second current, still undergoing research questions is a modern mathematician's listology. This is about two papers I'm trying to write at present. I'm trying to study different genres of lists in modern mathematics, how they figure in mathematical work, how they figure in theory and in literature, and how at the same time the lists composed by mathematicians and published in different media did prevent or create international mathematics in the period between early 20th century and 1950s and 60s. More specifically, I'm trying to see how lists are used in positively constructing mathematical knowledge on one hand, institutional geographies and identities at the same time. And how at the same time, the aspect which we are less familiar with is the negative function of constructing the same kind of images.
What type of lists are these? Can you
Yes,
give an
so that's my
example?
question. What's the definition of a list?
So there are actually a wide variety of lists. I distinguish between two types of lists. One list are those used in mathematical theory as such, like list of axioms, list of objects and concepts. Also epistemologies which redefine the value of the list, like intuitionist mathematics, which changes listing as such, especially axiomatic listing. And on the other hand, I'm taking a look at lists which are kind of related to the genre of bibliography, right? Listing currently existing mathematical work, which represents mathematics as a growing organism in a way. List of problems, list of members, more importantly, list of members of institutions, list of institutions as such, etc. So I'm trying to cover everything. And I'm trying to show that when it comes to the creation of the institutional image of mathematics, the epistemology of the lists created within mathematics is emulated and transformed into objectivisms. Objectivisms represented in the form of identities of mathematicians, of geographies of mathematical institutes. And this in turn are then translated into identities of mathematicians. This is very pertinent for me because I'm trying to address the elephant in the room of history of modern mathematics, which is that outside of Europe and the United States, there existed and still exist communities which are not included in the lists, neither of them. And there are many different obstacles to that. Aside from, well, access, there is also the question of language, of culture, of power, most importantly, etc. So I'm trying to, it's more of a bird's eye perspective on all types of listing which appear in modern mathematical work. And I'm trying to put them into all possible frames. There are emerging epistemologies which change the image of modern mathematics and how the list or listology is changed. And at the same time, I'm trying to take a look how this resulted into mathematical structures of disciplines of the growing organism of mathematics, which was in turn codified in bibliographies, right? And how these bibliographies were unable to list the development of mathematics or were able to list based on their epistemologies. To be more precise, like you had when we were speaking about late 19th and early 20th century, there were at least two different classifications, mathematical classifications around. They were used by two different bibliographies, contesting bibliographies. One was a structural classification of mathematics constructed after physical sciences and advanced by Felix Müller, which was, it was used in German Jahrbuch for die Vorschritte der Mathematik. The other was Revue semestrielle de publication mathématique, which was published in Netherlands and in France. And it used the Poincaré classification, which was not, so to say, vertical, but horizontal. So you had a series of categories which were put side to side. There were no structures implied by the classification. And these two, the differences between two can be really seen if you take a look at development of new bubbles within mathematical knowledge, like topology. They were differently capable of recording in what way new disciplines were emerging. And also, there was a problem of the list of the people who were reviewing for this bibliographies. Sorry.
Okay, so I have another question about this.
So which disabled actually, let's say the list of reviewers is really important, right? And these two publications had different lists of reviewers. They also had different lists of journals which they included into their feed. So all these factors resulted in their being unable or able to see certain developments within topology, classified properly, etc. Connect different results between mathematics together, etc. Yeah. So to put it simply, this is what I'm trying to catalog. I'm trying to create a list. I'm trying to show that the list of different types of listing has got a logic which connects different types of lists within a genre, and that there is a less well-known translation of the structural aspect of listing within mathematics into objectivisms, which then becomes the institutional mathematics as we knew it, right? It's some sort of a circle. I can speak more in detail later.
Another question.
Well, I have many questions. I don't know if this is the time to ask them, but there's a really interesting contemporary question here also, which is, are you familiar with the Matthew effect?
No.
Okay, so this is now having a resurgence because of the AI. And so the idea is that the rich get richer, the smart get smarter, or grants beget grants. But the new interesting perspective on the Matthew effect is because of AI generated references, then the same people get referenced over and over. So then who gets left behind are the early career scholars. And so it's a list.
It's
So
a list.
It's a list. I
But-
never thought of it until just now.
But a list requires a machine which operates using lists, right?
Yeah.
Before that, these were the communities, I would suppose. Communities, and secondarily, also political spheres of influence, the overseers of institutions. When I use the Soviet and Chinese example, I can also see governments with ideologies, right? And all this affected the listing of mathematics and the lists about mathematics and communities that represent mathematics. So yeah, but I obviously I'm far beyond. Before that question, right? I haven't thought about it. That's the problem yet.
I don't know. This is making me think about, I
Great,
didn't
thank
think
you.
of it as a list until just now.
Mm.
But also I think this is the notion of a list, like a grocery list. The notion of a list can be very simple. So I think for me, the
Well, it can
interesting
be.
aspect of this project is, what is the definition of a list? Like, that was interesting, there's a vertical list and there's a horizontal list. So already you have a very rich view of a list that goes way beyond my grocery list or my list of reviewers. So you have a very rich view.
Imagine that there is a new epistemology which changes the structural outlook of a discipline within mathematics, like Klein's Erlangen program, which was the epistemology, or I would call it epistemology, which underlined it was that mathematics and the intuition of space should deal with the dynamic space, right? And the invariants, if you subject different types of geometry to transformation, you get invariants. But what are the invariants? The same question was asked in 1966 by Tarski, who saw in invariants a listable concepts operating within different aspects of mathematics. And of course, Tarski's goal was logic, right? He said that when you subject mathematics further from Klein's geometric aspect to further transformations, the end result you get are the logical concepts. So listing is a necessary product, in my current perspective, is a necessary product of modernization, epistemic modernization of mathematics in this regard. So it's much more than just a grocery list, obviously. And another obvious example is axiomatics, right? List of axioms are not random lists, but they're structural lists. They propose that between elements of the list, there is a structural relationship, which is logical and which also implies a lot for all the subsequent lists within the system, etc. I think that we can.
Since we are already in the discussion, should we first get the people
Yes.
back up on screen? So that I think it will magically happen. Exactly. So now they all disappeared, and there we are. Good, excellent. So I wanted to make. I have two questions and a remark. Let me start with a remark because it's short, and it aligns very well with the two things that both Della and you said. When John Addison at UC Berkeley was running the Tarski colloquium, he would, and if there was an international guest who gave a talk, Addison would always ask, "Oh, you are from country X. List the 5 most important mathematicians from country X in ranked order. If he had a candidate from a particular subfield, he would say, oh, you are from subfield Y, list the 5 most important theorems in ranked order. So that was usually his small talk starter. And I think that highlights this importance that when you are forced to make these lists, this is not neutral, right? This is, something happens. When people are producing these lists, prioritization happens. Because you are now saying, okay, these are more important than the others, and that has an effect.
Also, a very important use of lists is in case of problems, right? List of steps within heuristics. Like if you observe Polya's, I'm not very well familiar with Polya, I must admit that. But what I know about Polya is that if the problems, a good example is his 1924 book of problems, quoted with Seeger, where he said that problems presented within the book are not set in a random order, but they're problems, right? Okay, this book was intended to teach people how to solve problems, but there's also a list of unsolved problems, which is a really important thing, I would say. A special genre within that family of different lists. Which is,
I have a very concrete question,
yep.
And you may know the answer to it, and if not, this is future research.
Yes.
So I saw on your slide the words logic, set theory, and mathematical classification very close to each other. And there is something that I've been telling my students from time to time, and I would love to see more historical research on that. And that is something that I actually experienced myself. Namely, when the categories logic and set theory in the AMS classification, 03 and 04, were merged in 2000. I was even part of it to some extent, but not really privy to the backroom deals. And I would like to understand why what's the history of these categories? What were the actual reasons that led to the merging of 03 and 04?
I would also like to.
Yes.
I would just like to point out that this may be a localized phenomenon, because as you know that there were different classifications of mathematical logic and set theory. Like in Soviet Union, mathematical logic and set theory were already together in one category already. And mathematical logicians in Soviet Union did produce results at that time. So they were classified differently. Yeah. We are speaking about the centers of power here, right?
Yes. I have my theories, which I will not talk about why this happened, but
I can say more about topology in Germany, which was also a person related thing, right? Because topology and set theory as well was a fishy thing in German mathematics when Klein was still around. But then in 1928, it came to an overturn, a new generation of leaders of mathematics that emerged in Germany, people like Feigl, who wrote the first history of topology, as it were, in German space, and presented it to the German Mathematikerverein. And then there was more, immediately the classification in Jahrbuch changed for that reason. But in 1928 was still kind of early. There was still clear definitions of what the field was before 1935. So you always require, I'm dealing with the early period. So I always need a textbook or a book summarizing the structure of what is at hand. This is a really important thing you require to do so, right?
My other question may just have the answer yes or no. So there was in some socialist countries, there was this requirement for all university level books to have a brief introduction that links this to Marxist-Leninist ideas. And I know that in East Germany, there was a whole industry of performatively writing these things to be somewhat hilarious. Was there something like this in China as well?
No, China took a different path from that. China only had 5-6 years of emulation from the Soviet Union, and then they wanted to reinvent their own science, which is a really interesting topic. Not obviously
There's a question in the back.
Yeah, I have a related question. My name is Joe Dahlman from the City University of New York.
And we're
And,
familiar with you, sir.
When I was first in China in the 1980s, I was invited to give a lecture at the Mathematical Institute in Beijing. And I spoke about Abraham Robinson, a person I was just finishing a biography of. And in the audience was Wu Wenjun. And Wu Wenjun is a prominent Chinese mathematician. He said, "Oh, do you happen to know anything about Abraham Robinson and Waszek in China?" I said, "I know absolutely nothing about it." And he proceeded to tell me about how when Janowski's translation of mathematical papers of Karl Marx were translated into Chinese, logicians took great interest in Robinson's non-centered analysis and used it to provide a critique of the calculus that enabled them during the Cultural Revolution to mainstream and justify what they wanted to do in terms of kind of Marxist critique about how calculus and teaching could be reformed using these new ideas. I was just wondering if you know anything more about that.
Definitely not. It is far beyond me. My knowledge of mathematical logic and mathematics in China and before Cultural Revolution. I've obviously also read your paper on the Karl Marx manuscripts, which is a good work. Something missing to me. Yeah, but well, Chinese history of mathematics in China has got several different periods, right? The conditions between 1950 and 1960 changed drastically. So the most interesting part of this history for me is that between 1956 and 1959, the Chinese mathematicians wanted to invent their own philosophy of mathematics, which was in a way a political thing to do. They even established a society for studies of dialectics of nature in order to recodify what the foundations of mathematics in Soviet context are. And mathematical logic and foundations of mathematics played a really important part in it. But this drastically, by 1966, this was overturned and everything, no.
Isn't that still the name of the philosophy of science institution? That's still called dialectics of nature.
They've still got the same journal circulating, but a different leadership, so to say. No.
Any other questions? We need to show off how talkative we are. Michael, say something.
Oh no, Jan's heard enough of me about it. Jan is five full years of my reactions to this. I mean, it's brilliant work, and I think hopefully you've seen why this provides such an insightful way into the problems of globalization and its very peculiar dynamics. I think this attention to listing in particular as a way of tracking the different kinds of say homeomorphisms between conceptual and institutional thinking in modern mathematics is really important, and sort of is an idea that our whole group has latched onto as going to be very important in the next couple of years, and as we try to come up with a story of the 20th century that isn't just about certain European migrants and their North American counterparts coming up with their sort of isolated things. So that's hopefully everyone else in the room is as excited about this as I am.
Yeah, I see excitement in the room. Okay, if no one else would like to say anything, so please. Brandon. Yeah, very good.
Well, you say very good. We'll see. It's just a little thought. Sometimes when you have a classification system, the most revealing thing can be the words that are used to label the miscellaneous bag, right? For a classification system, that you usually have to have a miscellaneous bag as well. And I was just sort of looking at that on the AMS so history, for example, gets thrown in there. Do you want to? Is that a thought that you can elaborate, or is it a dud?
Isn't the AMS quite systematic about this? Isn't it always none of the above, but in this section?
Something.
I think that's in every single section. That's the last item.
Yeah. But they have at the very top. They've got something like overarching.
00 is general, and general has a number of subcategories.
Yeah,
that's true.
Yeah.
In my case, the most interesting thing is C also, where you have a horizontal classification of things just parallel listed. C also means network, means that things are actually branching out. And this C also doesn't function when you're trying to do the tree thing, because the identity changes of different branches. So there's no wonder that in Zentralblatt, both these classifications were merged into one. But this doesn't solve this is still not the perfect system we would want to describe the growth of mathematics.
I mean, historians, we have this -03 classification, which is this wonderful, in any category in the general classification, you can say historical aspects by taking the number for that category and adding -03, but only if you also identify a 01A classifier as well. So it's a nice little sort of diagonal generalizations.
I remember when I organized a conference on classification in 2004 or 5 or something, that back then, one of the things that I was highlighting was that, because that mostly came from librarians, right? This was really about library classifications. And therefore things had to go in one place, right? So I've been doing this in Bonn for many years, that I had to decide into which category a book would go. And it had to be a unique place because there was a physical book that would go in a physical place, and you couldn't choose 2 places for it. And it's interesting how this has now been so completely taken apart, because for many things, because we don't have physical objects anymore, they can be in 2 places, because you can have a link to something.
I know we're at the end of our time, but Brendan, I think the underlying question of your question is really the important one, which is not everything fits in a list. The reason we have the miscellaneous category is because not everything fits in a list. So, anyway.
Yeah, I was just checking this clock here. It says -1:48.
Yes.
So we are at the end. I mean, normally we could go on, but because of this special situation, and we are forcing the poor IT personnel to stay until the end of the working day, I think we should wrap up, and we can continue this in the next online seminar, which is already scheduled. Deborah, can you remind us when it is?
It will be end of March. I'm not sure which day. I can check it, but maybe I write to everyone.
And who is speaking?
Dennis Darikaya will speak, and Mikkel Willem Johansen from Copenhagen will speak.
Very good. So that was advertisement for the next seminar. If you are interested and not a member, just email Deborah or me, and we will make sure that you get the Zoom invitation. And it will be technically much easier than this time. Okay, thank you all very much for participating.